Hello everyone and welcome back. In the previous video, I showed you how to work with the IDA disassembler and debugger, and also we took this very basic code and compiled it to an x86 or 32-bit version of a p-compiled executable. In this video, we'll take the same code and compile it to release x64 compiled p executable. So let's select x64, build solution, and go to the folder where the p executable is compiled, release, and load it into IDA. Do OK. And as we can see here, we have kind of the similar code, not real of a difference. Now, the difference we'll see here is when we'll start the debugging. But you can also already see that there are some slight differences in the disassembly. We see not push EDI, we see push RDI. So the registers here will use the R convention, which is for the x64 version of compiled executables. So basically, you still see use of EDI or even DI or SI, which are 16-bit versions. Really depends on the context, but in x64-bit, you will see more the usage of the R convention for x64. So let's start our debugger. Let's put a breakpoint with the F2, or just doing right click and add breakpoint. And let's start our debugger. Let's close here this window. And as you can see, we have the R convention registers in the right pane. You also notice that the address space in the hex view and also in the stack are different. They're bigger than 32 bits. So basically, we have the same type of registers like EAX, RBL, or EBX, ECX, but with the R convention. And you can see here, they have bigger values and address space. So again, we have the RAX, RBX, R6, which are general purpose registers for calculation stuff like this. RAX mostly will have the return value. The RSI, RDI will be the source index and destination index for copying data from source address to destination address. RBP and RSP are what builds actually the stack frame. We have the RIP, which is like the IP or EIP, which is the instruction pointer to the next address to be executed. So as you can see here, we have the 7FF675DC1070, which is the same address for the RIP. If we go and do right click and do modify value, we can modify the address to a different address here, and we'll jump this address. Or we can just do, for example, right click on an address and do set IP or set instruction pointer, and as you can see now, the RIP is pointing to this address that I pointed to. So in addition, we have more registers in the x64-bit. We have R8, R9, and so on till R15. So those are additional registers in the x64-bit. And basically, this is what I want to show you for this point. So while we'll go through the course, we'll see a lot of examples. We'll work with the Windows API functions. We'll reverse engineer malware, and you will see this type of things while with debugging and disassembling stuff. So for me, it was very important for you to get a taste of it or a little bit similarity with it, so I can be more comfortable in showing you the deeper stuff whenever we do malware analysis and reverse engineering. So thank you very much, and see you in the next video.